Here's an example of a proof in which you're moving from a true premise to a false conclusion. So we'll work it the same way that we do all other proofs, using this convention. It's really just a way to think about it. You don't have to go through all these steps. They're just ways to make certain that you're not missing anything. So I want to pick out the standard form, all are and all are. Then I want to look for term complements and also identify that it is false that. In this case, we know that exogenous morphemes and endogenous morphemes are not the same term. They're different, so they must be term complements. For whatever reason, and I don't have a good explanation for this, other than it's what the authors of your textbook chose. I would not ask you to work one like this without some kind of explanation if you were working it for a test. But for some reason, endogenous is the non. Again, you would think that exogenous would be the non, but it's counterintuitive. So I'll just identify that for you since it's hard to see, it's impossible to see really. But then addictive substances and addictive substances are exactly the same. So they're not term complements. And we end up with all M are A. We put our line for therefore, then it is false that all A are non-M. It should bring home the point further that we are only working with the premise that both of these are A statements. So when we're working with the premise that is true, all M are A, it will not, the traditional square of opposition and all the work that we do will not apply to the conclusion. Remember, we're just using the conclusion as a guide or a goal. We're only going to work with the premise. So that's what we begin to do. We rewrite our premise as the first line of our proof, and we can say given or assumed true. But again, it just means assumed correct. And then, again, conventionally, we just go to the square first. You'll see that there are different ways to work proofs, even in your book, that are equally as correct. I'm just trying to give you a consistent strategy with which to work proofs so that you don't have any kind of anxiety when you're taking an examination. You can work them all in a very similar way. And the first part of that is to go directly to the square. Now, the first or the only thing that we know about the square is what we get from the premise. So we know that A, the A statement, all M are A, which is our premise, is true. It does not have an it is false that in front of it. So we know that A is true. And we can figure out the truth values of the other letter statements on the square from there. So by the contradictory relationship, O is false, truth flows downward to I, or you could say falsity flows upward to E, either one. And then you could use subalternation or the contradictory relationship or any of the other relationships on the square to identify E as false. So here we're going from a true premise to a false conclusion. So we're going to need to end up with a false here, and the square is the place to do it. So I don't want to go anywhere on the square that is true. I only want to go to a place that's false, or use a letter statement that's false. I don't want to use O because it doesn't get me any closer to A. What I mean by that is conversion, obversion, and contraposition do not allow you to move between universal and particular statements, between all and no statements, and some are not statements. You can only move within them. So if I choose the O statement here, I'm going to end up having to go back to the square. And I don't want to do that. I want to get everything done at the same time. So I want to use the other universal, meaning the universal that's the other one, since I can't go directly there, to what the conclusion will be. And that is the right one because it has a false in front of it as well. So I change it to it is false that, and then I change it to an E statement, leaving the terms alone. And how did I get from A to E? Well, the relationship between A and E on the square is what I want to list as my reason here, because I'm listing how I got from here to here, not how I went about doing the square. So what's that relationship? It is the contrary. relationship. And I'm just going to carry this false down from here on out. But does no M or A look like it is false that all A are non-M? No, it doesn't. So I'm going to need to switch some things around in order to make it work. The first thing I'm going to want to do is conversion. I'm going to switch the places of the subject and predicate terms. That's all conversion does. And then what I'll be able to do is I still need to change this no to all and this M to non-M. And there's one thing that will do both of those, and that is obversion. It will take the quality and change it from no to all, and then it will replace the predicate term M with its term complement non-M. So it becomes all are, changes M to non-M, and it leaves the subject term A alone. Now, does it is false that all A or non-M look exactly like the conclusion? Yes. And if that's the case, if you've reached that point in your work, then you have successfully proven this argument.